Hello, everyone. Hope you are all well, and thank you very much for joining us tonight for DevSecOps Australia. This is our third meetup now. It could be fourth. Oh, I've lost count. Anyway, it's so amazing, and thank you all. So amazing to be here, and also thank you for joining. So we are a chapter of the global DevSecOps community, which is an inclusive community that educates and enables developers in application security. Before we get too far underway, though, I'd like to begin by acknowledging and paying my respects to the traditional owners on the lands that we meet today, with a special heartfelt respect and acknowledgement to the Wurundjeri people, who are the traditional owners here in Narromine, where I'm presenting from today. I'd also like to pay my respects and acknowledgements to Indigenous elders past, present, and emerging. So coming up tonight, or in this meetup, we'll be joined by Nick Jane from Dynatrace with an amazing talk on putting the sec in DevOps. Oh, such a tongue twister because I want to say DevSecOps, but that's what he's talking about tonight. So before we dive too far into that, I wanted to quickly introduce myself. For those that I haven't met yet, hello, my name is Developer Steve. So I'm one of the senior developer advocates at Sneak and the chapter lead for DevSecOps Australia. So DevSecOps is brought to you by Sneak, and our aim is to create a vendor-neutral space to share knowledge and best practices related to security software. We love feedback, and I'm going to copy this link over to the chat, because if you haven't yet joined us in the DevSecOps Discord, please do. And tonight I'll be monitoring the Australia channel. Well, actually, I'll be monitoring all the channels, but in particular the Australia channel on DevSecOps Australia channel on the Discord. So if you haven't yet joined us, please do so on that link I just posted. Actually, let me pop it up on the screen as well. There we go. Which you can also get to from the devsecops.io website. So, but please do join us there. There's been always some great chatter going on, and you can connect to community and we'll just geek out with peeps, which is, that's my favorite thing. So one thing we're always looking for too is you can request a talk. So we're always open and always looking for new speakers and new people to do talks and just share the knowledge and, again, just geek out. Very happy to help first-time speakers as well. So if you haven't done many talks before, or maybe this is your first one, please reach out, because I'm more than happy to help. I have literally done hundreds and hundreds of talks, like all over the place. So always looking to help and, well, particularly help first-time speakers. But if you're a seasoned speaker too and you just want some feedback on a talk, always happy to give it the once-over, so please reach out. The Discord is the best place to do that, so please reach out there. That being said, if you have got a question, please pop it in the Discord if you're on there already, or into the chat on YouTube as well, and we'll ask those through the end of the evening. One thing I did want to mention just quickly, because there's still a few days left, speaking of talks, is the call for papers for DevSecOps 24 is still open for a few more days. So I've just put let me bring it up on the screen. I've just put the link in the chat, but we are still looking for some more call for papers. So if you have got an amazing talk, again, please reach out if you need help, but that's the link to get those CFPs in. We've already seen a whole bunch of really cool talks as well, so even if you're not giving a talk, tickets are now open, so please go and grab one of the free tickets and hear from some amazing speakers. And again, join the Discord. Join the Discord. I feel like I'm using my Jedi powers now. Join the Discord. I have a lightsaber too now. Oh, it's the green one. Let me get the other one. There we go. Oh, it's not to scale, and it's spoilers. It's a lightsaber chopstick, but join the Discord. All right, enough about that. Anyway, let me take that off the screen. Cool. That was all I had for the opening. So let me, without further ado, bring out the amazing Nick Jane. Hello, Nick.
Hey, Steve. How you doing?
Really good. So looking forward to this talk tonight. And thank you for putting your hand up to come to a talk. This one's going to be really cool, and I'm not just trying to talk you up. And I hear the demo is going to be absolutely amazing in Work First Go. I may have just jinxed it just there.
See how that goes. And truly, I'm also really excited. Always looking for opportunities to talk about the fundamentals. A lot of the content today is focused on as you said, putting the sec into DevOps and really approaching it from the ground up. So, I want to thank everyone that joined, but let's have a lot of fun, and hopefully people will ask questions. We'll get to respond to those queries as well.
Amazing, thank you. Just before I let me bring up the screen. Just before I do, again, if you've got any questions as we go along, please ask it in the chat, or I'll be monitoring the DevSec on Discord, so ask it there, and we'll go through them at the end. But let me bring your share screen up, and over to you.
Beautiful. Thanks, Steve. So I'm just going to put this in full screen mode. Hopefully you can see it.
Yeah, perfect.
Awesome. So by the way, I can't see you. So just in case, if you give me a thumbs up, it's going to be harder. So I firstly want to say good afternoon and good morning, just in case people are joining from different geos. I'll straight away run into the agenda. So the agenda is pretty straightforward. We'll firstly together review the core differences between DevOps and DevSecOps. We'll then begin this conquest by asking some key challenges, which typically, throw a curvy ball at the developers and the security teams in today's time. We'll then talk about how those challenges result into need for a new role for DevOps security teams and developers. And then we'll then challenge ourselves with a brand new approach, which I refer to as the 3 quality gates. I like simplicity, so I think these quality gates are actually representing an easy and new methodology in the way you approach DevSecOps. And lastly, as Steve pointed out, we'll also do a short demo. Now, I like to keep a majority of my talks as vendor agnostic. So feel free to use any tools, any solutions that come to mind, as long as you're able to apply the principles that I'm going to share with you in this webinar today. And I know DevSecOps is a buzzword, but I feel it's a really important one. And I want to kick this off by saying security has an important part to play in application lifecycle and workflows. And I further want to say that I'll promise you I'll make this worth your while. So let's firstly review a typical DevOps flow. So you've got a pipeline, and I'm sure most of the folks who are listening today, they have some level of DevOps maturity within their organizations. And even for those amongst you who do this as a hobby, you may have some level of DevOps understanding. Let's redefine or define together what DevOps really is all about. So typically, application delivery is fairly automated. If you are following a DevOps way of delivering these applications. And secondly, there is a feedback loop for continuous improvement if you follow a CI/CD pipeline way of delivering these apps. Now, essentially, a mature DevOps practice is the foundation for any SRE or DevSecOps practice. So take this time to do a quick self-check and a self-assessment of where your team, you individually, or your organization stand in terms of DevOps maturity. Now, I like details. So as this next step, we're going to go into second level details and unpack what that single arrow that represents the DevOps flow, what that means in terms of steps and stages. So you got developers on the left side, and those developers might be using GitHub or GitLab as a way to manage their source code and share it uniformly across the organization or whoever needs to use that source code. They typically do source code check-ins. And most of the times, the first thing that checks off as a part of that first step initiated, you typically get automated tests executing. As soon as those automated tests have executed across those new applications, a build process takes place. And once that build process has taken place, the next thing that happens is those artifacts, those new packages get deployed. Now, all of this together typically formulates your CI/CD pipeline for your business services, But typically more automated tests trigger as soon as those new builds are deployed. And once everything checks out and everything goes as per plan, you typically deploy those artifacts into production. Now, one crucial thing missing here is exactly what we are going to learn about in a short while. But know that security is crucial, and I can't even emphasize on how critical security testing and the need for a shared security model is in that CI/CD process. And I speak to a lot of practitioners on a day in, day out basis. And these practitioners, they work for local and global enterprises in various sectors. And I've captured some of those sectors on the slide in front of you on the left side. Now, they're all exerting muscles to stand up a security testing practice across CI/CD and automation of such a practice. Because I think for those environments where automation doesn't exist, it creates a new challenge. And I want to talk about that challenge briefly. But this is where my backstory is relevant as well. So back in 2008, I was a lead developer for financial systems, and there was virtually no concept of application security. Most of the security concept was focused on WAF, the firewalls, the network side, data security, and some level of infrastructure and OS level reinforcements and hardening. It used to be months or years, sometimes, before we used to learn about an exploit or CVE in the critical services that we were building. And one thing I realized that it doesn't have to be that way. But before we start redefining, how we can approach application security, let's now relook at that same CI/CD pipeline. And I mentioned one thing that was missing in the pipeline. I'm going to introduce that thing, and we've been talking about it in the last few minutes. So no prizes for guesses. It's obviously the security auditing and the security check mechanism. And typically, a security professional have their own checklist. And via that checklist, they run a simple hygiene series of security tests. And in contrast to the way we develop software, we've obviously made progress in the way these security tests are run. And I like to look at it like those Russian dolls, the babushka doll. And Steve and I, we were briefly talking about it in the backstage before we kicked off this presentation. Now, that's where different types of tooling are used. And some tooling is focused on code security. Other tooling is used on quality, dependency security, even container security and infrastructure as code. Now, you have the super optimized DevOps process, which has omitted security testing for some of your environments. Apply that problem across multiple applications, and specifically in the cloud native development environment where a lot of open source software development happens. Now, typically after those security tests are run, an output is generated, and that output entails vulnerable libraries, access to sensitive data, container images, specific CVEs, and if you have SNCC-like services, you might be able to get your hands on the recommendations and the mitigation recipes. But this means a lot of headache for the business user and even for security teams who are typically looked upon as the slowdown factor for a lot of organizations. Now, if you dig into that headache, no matter how well developers follow the latest secure coding guidelines, and no matter how perfect their intentions are, some production code will almost always include at least one security issue. And now if you look at microservices and the amount of APIs they expose, you end up with much more attack surfaces. And a ton of services that microservices use, aka the service mesh, the databases, message brokers, even more apps and more attack surfaces are exposed. Now, these obviously run in a container for a lot of your environments, and that's where K8's clusters and Docker orchestration services come into picture, or I should rather say container orchestration, because you may be using other container services aside Docker. many layers of such infra and applications need security. And the security teams need to understand and learn these technologies to identify issues. So the new problems that arise as a result of that is most security tools were developed in the era before microservices and Kubernetes. And a lot of those tooling are playing catch up with these new ways of hosting your services, new ways of developing your services. And that problem gets exacerbated by cloud native development principles and tooling. Now, the other issue is security engineers lack methodology. And we've already talked about the tools that don't automatically fit the DevOps pipeline, which means now security teams that should be looked upon as enablers, they become bottleneck because of the manual security test in a world where we're trying to automate everything. So how do we change this? And I say this is where we enter DevSecOps. I'll take a quick pause and check if, Steve, there are any questions. If there are none, I will continue with the flow.
None yet, but also just wanted to do a quick shout out to Tim, who did a wave emoji chat in the chat. So hi, Tim. But no, I haven't seen any come through yet. But if anyone does have any, please drop them in the Discord, which I'm monitoring, or in the chat on YouTube. And yeah, we can go through those. But all good so far.
Thanks, Steve, and glad that Tim is following us. Now, as soon as we enter DevSecOps, I don't want to start with answers. I want to start with questions. And before we shape up DevSecOps methodology and approach, let's review what these specific questions are that need answering. And I also like to look at them because, I'm a hiker. I also like to look at them as challenges to conquer because I love walking in mountain trails. Now, the first question to answer is, how do you turn that extremely long turnaround time into snappy minutes or seconds and automate those steps? Now, the second key challenge is, if you land up with multiple CVs in that CI/CD process, how do you prioritize between multiple CVs? And the third one is, how do you answer if in production environments, which is where most companies are exposed, are you vulnerable in production environments, and where do you start? So that's where, again, it's linking back to the second point or the question, the prioritization challenge. And lastly, how widespread is this problem across tens of services, hundreds of services, and how do you automate the mitigation steps? So I want to firstly unpack the first challenge. And working with telcos, e-commerce companies, and banking institutions across ANZ and larger APAC, I learned that typical security audits and reviews take anywhere between half a day, and half a day is for more mature DevOps organizations, 2 weeks, and the average time is typically 1 week. I saw some snake survey data around this, and this is where I got the detail. The second one is, the challenge is exacerbated as developers deploy every hour across tens of applications and hundreds of microservices and its associated versions. So you land up with various versions, and I've got some early answers for you. So it can be contained with a view like this. And this is where you've got some filtering on the left side. You're actually monitoring your application with the help of observability-by-design, but you're looking at the observability data or that intelligence from a security CV angle. And you simply hit a filter, detected. And that's where you get multiple versions of your application in lower level and higher level environments, where you get told by a service that you have vulnerabilities. And on the right side, you have all the important context around those applications. When did those events, the release events, take place? When were the CI/CD workflows kicked off to deploy new features on those applications? And You also have a view into existing security or non-security related bug tracking systems like Jira or GitHub or anything else that you're using. And you also have the details on a specific vulnerability with a big attack vector. So here you're being told the criticality factor here is 9.8, which is obviously extremely serious if you follow the CVSS standard, the common vulnerability scoring system. And we'll learn a little bit more about this. Now, the second challenge or question to answer is, how do you prioritize when you have multiple CVEs? And the challenge with existing scoring systems like CVSS is it's too locked down and it assumes the worst case scenario. Now, these systems are designed in a way that they have to be risk averse, which means that for any given vulnerability, the assigned score assumes the worst case, and the CVSS specification does not allow for any modification based on topology. What is this service chatting with? Is it publicly exposed? And this is usually not factored into the risk score calculation, which leads to too many high or critical problems that creates a choice paralysis for teams that are supposed to mitigate these issues. And the second problem is the creation of lots of false positives. Because even if there is a dormant directory sitting in with vulnerable code that is not a part of your application in runtime, your CVSS scoring systems assume that is a serious problem. So I want to expose some examples of CVEs. So remote code execution is one such CVE, arbitrary code execution, deserialization of untrusted data, improper input validation, and all the different types of attacks that come our way. Now, this is where the right system pinpoints if vulnerable code is called in production applications, which is where traditional application security tooling does not really focus. So most of the focus is on the left side of the SDLC. And I really appreciate, I want to iterate that SNCC hasn't paid me. In fact, I work for a different company, but I really appreciate SNCC vulnerability intelligence, which is automatically linked to a smart system with a view that is being shown in front of you. And every time there are material changes in the environment of that application, the severity and the impact of the vulnerability is diagnosed and updated. So in an ideal service, you get a prioritization in front of you, like top recommended fixes. So before touching anything else within your complex ecosystem or your enterprise environment, fix the Log4j issue is what you see in the screen in front of you. And then it says you may want to think about upgrading your struts framework and also look at upgrading your commons file upload dependency and so forth, so on. So the objective here is to bring into context any public internet exposure, attack vector, or access to sensitive data assets on that vulnerable application or environment. And lastly, if we progress further into the other questions and challenges, you ought to learn and understand at what scale are you exposed. So as I said, most tooling focuses on code level vulnerability. They focus a lot on static and dynamic application testing. They are unable to answer questions like how widespread this issue is. And you are, again, going back to some of the early problems that I mentioned, they are unable to fit into your existing CI/CD mechanism in form of an automated security testing scenario, which helps you to shield right, but not necessarily by slowing down your CI/CD process and increasing the time to market for new features and services. Now, Steve, I'll take one more pause and see if there are any questions or any acknowledgement of what I've been sharing before I continue the presentation working towards the demo?
Actually, we have a couple of questions. Well, one that I'm going to frame as a question from Tim. But first, we have one from Tom, which is, what are the biggest impact things on AppSec engineer? What are the biggest impact things an AppSec engineer can do for improving security in their organization? Is the question.
That's a fantastic question, Tom, and plenty of things they can do. Like I'm going to share with you in roughly 2 slides. I can see in my preview at the bottom, in roughly 2 slides, I'll show you exactly what developers can do. And the beauty is, for the DevSecOps methodology that I'm proposing, multiple stakeholders partake in that workflow, just like a CI/CD workflow. But more crucially, I want to talk about what developers can do better. So just stay tuned for a few seconds, and we'll get to that bit. I'll again go to Steve. Steve, there might be another question.
Yeah, well, I'm going to ask it as a question because I think it's a really good one and super important.
Yep.
But before I do, just going to mention the Discord again. So this is where that conversation is taking place. If you haven't yet joined us on Discord, please do, because there's some interesting discussions in there. Anyway, this particular question this conversation I'm going to frame as a question, which is, as far as security policies go, and you might cover this in the upcoming slides as well.
Yeah.
Do you think it's I'm going to say best practice for certain programming languages to be excluded from a particular stack because of security concerns as part of the security policy?
Yeah, fantastic question. I'd say if you have the right application security tooling, which is compatible with your language of choice, you don't have to exclude certain programming languages. And I was just reading on Stack Overflow, like many other things, I saw that PHP and Java have the highest reported CVEs and exploits out in the marketplace. So it doesn't mean you stop coding in those languages. If you have the right application security, the language security tooling in runtime at hand, you can continue to code in your most favorite languages, provided that they give you infrastructure optimization and cost optimization benefits, and even the ability to keep your teams vested with the language of choice. So again, we'll address this question in a lot more details, but that's my quick response to that question.
Amazing. And keep those questions coming in. I am monitoring the chat and the Discord as well. So yeah, keep these amazing questions coming. Anyway, I'll hand it back over to you.
Thanks, Steve. So now, to answer that scale question or challenge, you ought to be able to answer these micro questions. When your tooling is telling you that you have vulnerabilities in your production and pre-production environment, it should be able to tell you exactly which processes are affected that support your most critical customer experiences and your revenue pipelines or revenue critical services. The second is, it should be able to not only tell you the root cause, but a recipe to remediate, or the recommendations to remediate. And it should be able to pinpoint when that problem was first tracked and how is it evolving as you go. And it should be able to pinpoint all those surrounding ecosystem services that could be exploited or are affected as a result of this vulnerability. Now, other questions could be, which container images are affected in the cloud native world? And what components within those container images are affected? To give you an example, it could be a certain version of the Log4j dependency that you're using in your service, or the Spring framework or the Spring Cloud function version that you might be using. Now, this is where a view like this really helps you, where you can specifically pinpoint the component and the vulnerability in your production or non-production environment. And here you can see it says Insights by SNCC. So if you click on that link, you're taken into the recipe and the root causes and the exact steps on the back of all the POCs that were conducted in the field that SNCC maintains a database on. Now, it also gives you a view into the severity, which is more reliable and robust than the commonly known CVSS scoring system. And this is where, when we get to the demo, we'll review a lot of these things in more details. So now, to answer that question that was posed by Tom, let's go back to defining that missing link. And now you notice at the back of the CI/CD pipeline, I've introduced a security test gate. Now, if you are to do it even better, your DevSecOps methodology really has security at the tail of each and every major step and stage of the workflow. So you land up with a strategy that provides code security, container security, dependency security, and infrastructure as code security, and not just in lower level environments, but across the board leading into production. So it really looks like this, where you add a little automated security step at the tail of each and every substage of your DevOps workflow. And this inadvertently reshapes the roles of developers, DevOps, and security members. So let's firstly review, what does it mean for the developer? So for developers, it means that we're now responsible for security. And I'm not sure if you remember, I mentioned when I was a programmer, we didn't have any such responsibility. But if you explore this area, there is a lot of excitement to be had. And it actually enables the developer, rather than add more roles to their day-to-day responsibilities. And this is where security team becomes a facilitator and an advisor for the developer, rather than traditionally, they are seen as an external police that blocks dev teams. Now, this also means a change for the security professionals. And this is where security teams go from being creating or identifying the tools or slowing down the DevOps pipeline. They take on this objective of creating security policies, select tools that meet the automation criteria for detecting security issues. And this is where you will run into tools that fit the category of source composition analysis, and even static and dynamic application security testing. And you must have heard of tools like Bandit, SonarQube. Obviously, Snyk is one of the favorite tools. And what I learned recently is more than 1.5 million developers use Snyk globally. You also run into tools like Twistlock. Dynatrace comes into the picture as well. And security professionals have this new objective of training developers and operators to interpret the output of these tools. So let's see, how does this reshape the CI/CD pipeline? Now, your developer is sitting at the top in that overarching function where they seek input, or rather output, from these various steps and stages. So firstly, pre-commit hooks stage, they will be receiving inputs. And then from the build phase, from the deploy phase, and then the post-deploy automated testing, and even production environments. And this is where a lot of those tools that I mentioned get used. So just a quick one-on-one, any post source code check-in step, those tooling from an application security standpoint, they get categorized as source composition analysis, or SAST, and even SAST. The build phase application security testing can be categorized as DAST. And if you write up these acronyms or write up these names, you can do some reading on these category of tooling, which will enlighten you further in terms of specifically what they do. Now, let's quickly go through the benefits of taking this approach. So we have talked about the how. Let's go back to the whys of a DevSecOps practice. And we started with the DevOps model and we added the security testing, which is really putting the sec in the DevOps. But let's quickly review all the benefits. So first benefit is deep and frictionless security integration benefits that improve your security posture and collaboration between various teams, developers, testers, operators, and security teams. Then you also end up enabling deeply integrated security that increases the sense of shared responsibility. So security is no longer a point-in-time feature, but it gets incorporated right from the design phase, where you incorporate security into building, deploying, and even securing your production workloads. And if you execute this step well, it leads into a transition from the DevOps practice to a DevSecOps practice, which reduces cost in terms of identifying CVEs. And you all know, if you ever had a major security event or a minor security event, you know the cost of those events and what that means in terms of reputational risk for your organizational and even operational cost of mitigating those risks. But I like to look at things from a business outcome perspective. So what this means in the marketplace is greater trust in the security of the developed software and the way your organization embraces new technologies that enhances your revenue growth and expanded and even ends up expanding your business offerings. So I want to show you this in action by using a recent security CVE that was reported on, from memory, 29th of March. So this was related to, and not to confuse you, there were two separate issues. One was Spring Cloud function related, and the other one was Spring Core framework related, which is Java framework, not the cloud framework. Not the cloud function framework. And this is where those organizations that had Java workloads, which particularly matched a certain condition, like they were using JDK 9, they had Apache Tomcat as the servlet container, and they packaged this application as the traditional WAR, in contrast to a Spring Boot executable jar. They were the ones who were exposed. And here you can see a tweet from a certain person on Twitter who says it was first leaked by a Chinese security researcher who has since deleted their account for whichever reason. Now, this is how it can work in action in those kind of scenarios when a new vulnerability is exposed and hackers start combing the internet for publicly exposed applications that use those frameworks or use those specific services surrounding which those CVEs were launched. Whenever those remote code execution, as an example, is exploited, your tooling at runtime detects that particular vulnerability, and it, in a more sophisticated environment, it blocks that attack. And then it also provides your dev team and your operator team with this specific recommendation on how to fix that issue. So if you follow the workflow, you could have approached it in a more sophisticated way, where in the build phase, you use an image scanner, which categorizes as SCA tool. And then in the deployment process, you use an image scanner on admission controller. And don't worry about if you don't understand all these technicalities. It will all come to light when I demonstrate how this works in action. And then lastly, in runtime phase, you use a runtime detection engine that detects any malicious behavior or an existence of a vulnerability in an already deployed host, pod, or process, not at the OS layer, but on an application layer. So I want to share this experience that we had at Dynatrace when the Spring for Shell vulnerability was deployed, or sort of first registered on 29 March. Somebody sounded the alarm on Twitter And SNCC was one of the first organizations to list it on their database, which is when Dynatrace started finding these vulnerabilities in production environment with the help of our scoring engine, which uses the CVSS framework as a base. And from that time, it made it to the National Vulnerability Database on GitHub. And I want to again take a pause and see if there are any questions, acknowledgements, or comments based on what I've shared so far. We're not that far from the demo, but we are literally going into the more juicy part, which is the 3-step quality gate. So, Steve, are there any questions, any acknowledgements?
None that I can see, but everyone should keep those questions and comments coming in. Actually, I have one that came to mind when you were talking about the developer being on top of that, that pipeline graphic, which is, are there any hot tips you have for getting code tests to pass first go? Now, I'm asking as a friend with that one because that drives me crazy.
So I was going to ask you to repeat that second half. Can you please?
Is there any hot tips for getting test scripts to pass first time? And I'm talking about Jenkins and the likes, because I mean, from experience, you spend all that time like crafting your test script, and it's going to fail because there's a space in there somewhere. It always drives me crazy.
Yeah. I wish I had an easy response to that, but I'm a victim of that same challenge. So hang in there.
If anyone has any questions or comments, please drop them in the Discord or into the chat. So it's still monitoring. But other than that, no, nothing at the moment.
Sure. Thanks, Steve. So I'm going to speed up a little bit. I'm a student of philosophy and technology. So this really resonated with me. Before I unpack the new methodology, Buckminster says that you never change things by fighting the existing reality. To change something, build a new model that makes the existing model obsolete. So I wanted to share one such model with you where you've got a few different steps. And the first step in that model introduces, and these are not hard gated mechanisms. So it doesn't mean it's going to slow your DevOps pipeline, but these are automated steps that you can bake into your pipeline in order to execute automated quality gate, in order to execute a security gate. And the dev optimization phase and SLO-driven ops are really concepts that should be embraced by developer teams and operator teams. So you got an application that starts right at the left side of the SDLC. And as it progresses towards production environments, it has to go through, think like when you enter an airport, you get scanned for security and you get scanned for being a quality customer. So these are exactly those same processes. So think of it like going through a scanner. Now, what I wanted to show here is the precondition for those scanning mechanisms. And notice here, the important part to note is you need to have a common data platform that collects information from all these disparate steps and stages of your application lifecycle. So the concept and the objective for the first gate is to reduce the cost of fixing bugs. So rather than having bugs slip into production, you fix them early, and you're really promoting a bug-free application or feature package going to higher level environments. And the objective behind the build quality gate, which is a very new concept, and it has existed with testing teams in terms of detecting hotspots in that step and stage of the application lifecycle, but it's not SLO driven. So typically, most teams, they simply use a response time or a load as a checking mechanism. But here, we pretty much stand up multiple SLOs, service level objectives, as a way to assess if this build is a quality build and if it's ready to be put in front of the customers. Similarly, a very simple check from a security gate standpoint, and the check is, Does a vulnerability exist? If yes, send this application back towards developer so that the developer can fix that application and remove that vulnerability. So it might be as simple as bump up the version of the Spring Cloud function or the log4j library. And finally, it goes to the SLO-driven operations team, whose objective is to keep an eye on their error budget for their revenue critical service. Now, I'm not going to spend too much time on what each and every gate does, but I'd rather show you in action how these work. So here is an example of a SLO gate where you track the most important SLOs across most critical service and user journey on a view like this. And for a quality gate perspective, the objective is to have a simple view where your services break up and get scored by different SLOs. So you notice in the first version of the application on that screen in front of you, everything is green except one little thing at the bottom, which is host disk queue. And for the next version of the application, there are multiple things that are not meeting the SLO, which is the service response time P50 does not meet the expectation, and so forth, so on. And those issues are captured at the bottom in terms of a report. So if this build is stopped from going into production, it will basically be sent back to the developer with the exact prescription on what quality changes, optimization they need to make. Now, similarly, a security gate is super simple, but I want to introduce it with the help of a more detailed workflow since we are at DevSecOps. So here, the challenge is to stop releasing new software that contains log4j-like vulnerability. So the first step is your service, in this case, Dynatrace, identifies that log4j exists in that new build in the higher level environment, but not production yet. And then as that CI/CD pipeline executes to kick off automated testing and to kick off the quality gate, this build is going to be blocked from going into production because it has an existing CVE. And that's where conceptually what happens behind the scene is your new build is automatically packaged together with observability as code. So Dynatrace is deployed and configured within that application, within that new build that is about to be deployed. And as soon as automated tests are executed, the quality gate is triggered, and that pass-fail mechanism basically provides that feedback to the developer. So if it's a fail, it stops the pipeline gracefully, reverts to the blue-green environment, and disables the feature flag. And if it passes and there are no vulnerability found, it promotes to the next stage and releases to the production environment and enables the feature flag. So with that, we'll see a quick 5 or 10 minutes demo of how this works in action. So this is where I'll be using Dynatrace as an intelligent and automated, I call it magnet, for problems that help deliver flawless and secure digital interaction. And I'm going to use SNCC, on the other hand, which acts like Grammarly for code, and it provides you access to the rich vulnerability database to give you the recipes, to give the developers and the operators the recipe to fix such issues. So I'm going to swerve into my demo environment. Hopefully you can see the screen. Now, firstly, I've got a simple dashboard here that shows me the total open problems and the total closed problems, because a good team will constantly be fixing security problems. So you also want to keep an eye on the trend of incoming issues versus closed issues. And then you want to slice and dice the issues or filter them by high criticality issues and medium and low criticality issues. And this is where you get brought into a screen like this, where you get shown all those 259 vulnerabilities that were shown on the dashboard, categorized by 6 highly critical issues, some low-level and mid-level criticality issues. And it also shows you how much protection your overall workload has in your production environment. So this answers that first question, or if you remember the challenge, are we vulnerable? And it also shows you a view into how widespread that problem is. So what I'm going to do is I'm going to go from here into the second screen, which answers that prioritization question, which is, what do I focus on first if I have multiple vulnerabilities detected in my environment? And this is where I'm being told, the top recommended fixes are fix the log4j core issue, which impacts quite a few applications in your environment. But since the Spring framework vulnerability is what we have seen as the new talk of town, I'm going to drill into that particular scenario here and answer those, how widespread this problem is, and all those sub questions that I had on the slide around which containers, which processes, how do I mitigate this, what is the root cause, what else is affected, what's the context of this problem, how could an attacker exploit the peripheral systems like databases, message brokers, and whatnot that sit in the periphery. But I'll pause here since Steve has come back on video. Steve, is there a question or comment?
No, I was just going to say, can you hit Command++? I had to look at what button it was. Command++ a few times to make it a bit bigger, please.
Is better?
Oh, yeah, perfect. Thank you. That's a bit better. That was the only reason I was coming on.
Yeah. So we're down into the second level view where we are answering those questions, how widespread the problem is, and how can I mitigate this issue? So this is on that CVE that was recently registered in NVD as a CVE. And notice here, Dynatrace first detected this issue on March 31st. Not a lot of time had passed after this issue was registered as a zero-day vulnerability. And this is where we update this view every 15 minutes for each and every CVE within your environment. So notice here, the scoring mechanism is an improvement on the CVSS score, which we refer to as Davis Security Score. So Davis is the AI ops engine within Dynatrace that baselines problems, including security problems, and keeps an eye on the topology of the service that is affected and brings in a lot of context and pinpoints the root cause of that security problem. So here we are being told that this is a 9.8 critical risk vulnerability. And the reason is it has public internet exposure. It has access to sensitive data assets. And there is a public exploit available for the CVE, and it currently impacts 19 services within your environment. And this is the root cause. This is the vulnerable component. Now, if your teams were already actively working on this issue, they could hit the mute button and choose a reason for why they are muting this CVE. So they could say something like, this is a false positive, hopefully it is, or the vulnerable code has been validated as not being in active use, or the configuration was not attached. And there are other reasons as well. Now, if you scroll deeper into the screen or use the contextual menu, you firstly want to grasp the problem context. So the problem context here is there are 4 exposed processes, and you can see the full view of those exposed processes with a view into the service level objectives and even golden signals. If you follow the Google's practice around golden telemetry, you can also view the golden signals and the health of this service from an observability perspective. Now, if you scroll further in from SNCC's integration, we're able to see more details around the vulnerability and exactly how to fix it. So if you click on more details provided by SNCC, you firstly get told this is the CVE number. New screen, you get a view into scoring, which aligns with Dynatrace scoring. And you can also see exactly how to fix this problem. So a recipe on fixing this problem and any updates that has been had since the day the CVE was first registered. Now you also get a view into how critical this is from an attack complexity and other important views like attack vector type, which is network, user interaction none, and a lot of critical details. So the fix is simply upgrade your org.spring framework library to such and such version or higher. And if I'm to validate, the version detected by Dynatrace must be lower than that version. So you could click on vulnerable component and be taken into which vulnerable jars were detected within your application process. And here I get shown all the vulnerable jars, which are lower than the version which was recommended to the developer in terms of an upgrade. And if we scroll up, you also see all related entities which are exposed. So there are database exposed, and here are those two databases. There are all these hosts that are exposed, several business applications that are exposed, and it also shows the Kubernetes workloads and clusters that are exposed as a part of this vulnerability. Now, I'm mindful of time, and I wish to close with the container images which use the vulnerable component have also been automatically detected here. And right at the bottom, you can see each and every container image which may need a permanent upgrade of that Spring framework if you are to mitigate this issue. And then you can come back to your vulnerability dashboard and validate. After you've fixed all these issues, you're actually able to validate that a lot of your high criticality vulnerabilities are gone from your dashboard. So I'll stop there and go back to Steve. I wish I could show you a lot more in the demo environment, but hopefully, that demo gave you a view into how you can embrace DevSecOps and really put sec into your DevOps practices.
That was amazing. Hang on, I have a sound effect for this. There we go. BYO audience. No, there's plenty of people watching. Anyway, if anyone does have any questions, comments, please drop them into the chat. Actually, we have a couple to go through, but we'll get to those in a moment. That was really cool, and also I'm glad that the demo worked and everything was favorable there. But super interesting. One thing there, I love that you mentioned Spring for Shell, because I literally did watch the same thing unfold on Twitter. And was like in one of our Slack channels talking away to colleagues going, I think people are saying this is bad, before we started to jump on it and do all the security research and all the blog posts and whatnot. So, and I think, there was a lot of people still rattled for Log4j, which we've all felt the ramifications for. So, it was super interesting to see unfold. And I love seeing that you used it there, because these vulnerabilities surface really quickly. So, And
Steve, to your point, there was a question where we were asked, what are the biggest impacts an AppSec engineer can do for improving security in the organization? So I feel it's taking actions on vulnerability data. So what I find time and time again is a lot of these details can be surfaced if you have the right tooling. But even after a few weeks, a few months of pointing out these CVEs that exist and put the customers that use these applications at risk, even weeks after knowing about these exploits, nothing is being done to fix them. And I think that's the
Yeah.
number one challenge for AppSec engineers, is to firstly get the right tooling, but secondly, and more importantly, to take actions on the data.
Yeah. This is actually, this is a very interesting topic. And if anyone's looking for a call for paper submission idea, I would love to see something around this, because this one in particular is one that, well, has just come up again for one of my favorite ecosystems, PHP. Yeah, I don't mind saying it. I like PHP. There's a library that recently surfaced that has 200 million install, or over 200 million installs. And there's an RCE that I turned into a reverse shell, and then got a CVE listed for it. So yeah, and it's still waiting for approval. But anyway, no, I think this is a very, very interesting point, and something, as a developer, something that's like I've sort of become more aware of trying to raise CVEs, is half the battle is almost proving that this thing is a problem, and then the other one is like getting it officially recognized, which is a whole other thing. There's a quote. I'm going to do it. There was a quote from, and you know what's interesting with this is also, sorry to pivot and hijack things slightly, but there's kind of that line between, do you think there's a line, actually let me reframe this as a question. Do you think there's a line between a bug and a vulnerability?
It depends on your definition. I think there's definitely a line. Like a bug could be a bad HTTP response code or an error within your code. But I think vulnerability, to me personally, is a lot more serious. So one could break your user experience. The other one could make your customers lose trust and credibility with your organization. So I think we all know which one sounds more serious.
Yeah. And so just for context, the only reason I ask is there's a vulnerability that's appeared in and I'm going to call it a vulnerability, irrespective of what the core developers say, in a very popular coding framework that I'm been using lately. And I don't want to mention any names. Anyway, it was originally started as a vulnerability. It was a use after free vulnerability that somebody exploited in a capture the flag, and was actually able to inject code using it. And the core development team for this particular popular 20-something-year-old language dubbed it a bug, not a vulnerability. But even though, anyway, it's a whole thing. It's a massive debate right now. Many blog posts coming. But I think it's interesting that there's that line of like, and do vulnerabilities start life as bugs until they're deemed a vulnerability? Like, yeah, it's so many. Anyway, if anyone wants to do a talk on it, I would love to have that as a talk. So
yeah, that sounds like a great topic. I'll certainly join and tune in as well. But Tom and David made a couple of great points, and I'm looking at the chat window. Yeah. So David actually answered your question on the best way to mitigate those automated test flows. And I wanted to comment on, keeping it simple, keeping it short. So that's the one thing David has mentioned. But the other trick is to learn one framework really well, which most people don't bother with. There's a lot of code grabs that happen online. And Tom asked, why don't actions get taken? Is it resourcing? It's actually two things. Is not having the right tooling. And I mentioned that a lot of the tooling is playing catch up with the cloud native development practices and the modern infrastructure environments and the way these applications get delivered. The second problem is, and it's changing because, I was going through a CISO report from a credible organization as well. And what they were saying is the CISO is finally getting in front of the board members. So they are winning more budget and they're getting more attention because board members have finally realized the importance of a rock solid and airtight security program. And this will also mean we'll see a lot more resourcing put in place, but a lot more training put in place for traditionally non-security focused resourcing. So AKA developers and testers, I think they'll be receiving a lot more support and advice and coaching as well. So Tom, to your point, if that's not happening in your organization, you definitely want to potentially be that change agent. And, you've got great people like Steve to guide you in terms of communicate the right way and obviously arm you with the right data. So obviously leverage folks like Steve.
Also, there was some chatter around this in the Discord too while you were doing the talk. And in particular, the question around, is there enough time to fix security issues found if developers build at the end of the sprint? And I think this is going to come back to what you're talking around using business logic of, can we afford this to go to production? Like, clean up later or clean up now. I'd prefer to do it now.
Yeah, you nailed it. And Graham also commented with a very interesting feedback. One person's bug is another person's vulnerability. So
yeah, that's true.
Very true. Very true. And that's why I started with, depends how you define it. So
yeah. If actually, I like this one too. If nothing bad happened, it was just another bug. This is literally the tree of the forest of the security world. Is if no one knows about the bug, then did it happen?
That's exactly right.
Awesome. Keep the. Oh wait, we do have one more question. Will it impact confidential integrity or availability to determine whether a bug is a vulnerability at a high level? That's from Tim, or he's typing again. Maybe I got that wrong. Will it impact confidential integrity or availability to determine whether a bug is a vulnerability at a high level? ? I think that's in form of a question. But he's typing. I can hear furious thumbs because I know he's also on his mobile.
Right.
No, that was an amazing talk. Thank you, and also feel free to submit that to the call for papers as well if you wanted to do that at the DevSecOps Global Conference as well. Wait, Tim's still typing. All right, looking for questions, but I don't think there are any more. But please, everyone, if you haven't already, join us on Discord because we had some pretty good discussions in there. Well, not only tonight, but all the time, but also tonight there was some pretty good discussions in there. So anyway, thanks so much for such an amazing talk tonight, Nick. It was so great to have you, and that talk was absolutely amazing and spot on.
And Steve, thanks for having me, and thanks to the audience for asking all those questions and sharing their wisdom as well. I look forward to joining one of the future sessions as an audience and keep learning. I think that's one thing we all can do is keep learning new things and stay on course.
Amazing, thank you. Just to wrap up for the end of this meetup, and thanks again to Nick. It was great to have him on session today. And also thank you all for listening, and we really hope you enjoyed it. If you haven't yet joined us, please do join our Discord. Let me grab the link for that again. I'm just going to put it on screen. You can also get to that through the DevSecOps website. Stay tuned for our next meetup. We've already got a talk lined up for the next one. Actually, it's a really good talk from one of our friends from OWASP, I believe, but stay tuned for that one. We'll have more details just after the Easter break. So that's all we have time for. Let me turn that one off. That's all we have time for this meetup. So please join us again. Again, if you haven't yet join on Discord. Call for papers open 2 more days for DevSecOps 24. Tickets are free for that. So if you're not getting a talk in, please also grab a ticket to that. They're available right this now. Yeah, that's a word. And we'll see you all soon. Thank you for joining.